Hello, my name is Susha Mishra. I'm standing in the Terry Fuller Petroleum Engineering Research Facility at Texas Tech University. Behind me are a set of water and gas pipes that are used to transport natural resources throughout our state. In February of 2021, there was a major snowstorm that left many of these pipes vulnerable to freezing and cracking. And I was wondering what we could do to protect our pipes from that situation from ever happening again. Luckily, I think I found some inspiration here in the city of Lubbock. The prairie dogs at Prairie Dog Town and all across the Mono Estacado plains of West Texas have developed an adaptation throughout their tunnels and mound burrows. One end of their tunnel is asymmetric compared to the other end, which allows for a passive air ventilation system. On the tall, narrow end, the pressure is lowered, allowing air to escape much faster. And the tunnel entrance, there is a shorter but wider mound that allows for pressure to build up and for air to travel inwards much slowly. This modulates the air pressure at different points and changes the speed of airflow. I was wondering if I could connect that principle to a Venturi tube. This Venturi tube can alter the pressure of water at certain locations that allows for water to travel at faster speeds in areas of lower pressure. I believe that we can use that to find a better solution for our pipes in the state of Texas by reducing pipe exposure to freezing conditions and temperature vulnerable zones by lowering the pressure in those regions and increasing the speed of water flow. The same thing can be said for natural gases. It is estimated that about a sixth of all the water and natural gases transported throughout the state of Texas and the United States as well are lost due to leaks and cracks in freezing pipes or pipes exposed to other conditions. This is why we need to come up with a solution right now, and I believe this will do the trick. So without further ado, here are the steps in creating our theoretical Venturi tube pipe system.
There are different types of Venturi tubes that are often manufactured and designed based on its function and purpose. Some of the most common materials used to create Venturi tubes are the following: PVC pipes, air compressor, vacuum pumps, bronze, stainless steel pipes, cast iron, fiberglass, carbon steel, and chromoly steel.
One of the most environmentally friendly resources to manufacture a Venturi-based pipeline is the use of PVC equipment. PVC pipes are made from chlorine and domestically produced natural gas, and it can be used 100% effectively for productivity and is 100% recyclable. The material needed to make PVC pipes, as well as the energy consumed, is a quarter that of making concrete pipes and a half of that for making iron pipes. Making PVC pipes also does not require the use of smokestacks, thereby effectively reducing the pollution and greenhouse gas emissions to the environment. This specific resource has gone through numerous life cycle analyses and is accredited by the Bureau of Labor for having far fewer manufacturing-related injuries and illnesses in each phase of production for PVC pipes compared to that of other materials. PVC pipes have a smooth surface and leak-free joints that reduce the probability of leakage by 40%. Once again, I said that a sixth of all of the natural resources transported through these pipes are leaked out into the environment. Besides the ease in transporting, installing, and maintaining this pipe, PVC pipes also have an elongated life expectancy of an estimated 110 years.
Air compressor. This device uses gas or pressurized air to transform power into a different form of energy. There are 3 different classifications of air compressors depending on the amount of pressure it produces. This includes low-pressure air compressors, medium-pressure compressors, and high-pressure compressors.
Air compressors can run more efficiently when power usage is less during periods where water flow through the Venturi pipe system or gas flow is less. These compressors should be maintained on a regular basis and should also run at a pressure that is not over the required pressure, as running over that can open the door for leaking pipes. The air compressor's condensate range should be at a zero loss to ensure that the valves do not stay open and leak out compressed air. The air distribution through the compressor should happen through a short tube and one that is large in diameter to ensure that there is no pressure loss. Lastly, heat produced from compressors should be reused for businesses and consumers' benefit, such as heating water or distributing warm air to a room whenever necessary.
Vacuum pumps. This operates by removing gas molecules from the vacuum chamber. There are different types of vacuum pumps depending on their vacuum range. This includes primary pumps, booster pumps, and secondary pumps.
Vacuum pumps can greatly benefit from the installation of a variable speed drive, or VSD. Such a device can modulate the speed and pressure of the vacuum pump system in the Venturi tube by using pressure reading sensors distributed throughout the tube system. This can save 50% or over on electricity costs and up to 80% off of energy usage. The same maintenance rule from air compressors applies to vacuum pumps, as they should not run above the required pressure and should be maintained on a regular basis.
Okay, so today I will be talking about the processing of the Venturi tubes in the vacuum. So the making of the Venturi tubes requires many different types of materials and machines as well to create these. And there's a variety of materials that are all needed that have been talked about before. So to begin, you will need a glass jar or a flask, which is used as the container that will hold the vacuum of the Venturi tube. And a glass jar is created by using melted sand and then pouring it into a mold. Next, you'd have to buy a vacuum module if you couldn't, it's kind of complicated to make your own. And this has a plastic housing that needs to be removed. And then once you have removed this, there are three parts. Two of the parts are metal, which have been mined from natural resources and then melted down in their needs. And these two parts are the vacuum port and the air compressor inlet. And then the third part is this plastic piece that has three different ports inside of it, where the vacuum module and the inlet goes inside, and then has one hole that will be used later. Okay, so next, a plastic tube will be connected to the vacuum port, and this tube has a hose barb which will be pushed into that port on the other plastic thing, the thing that has three holes in it. And this plastic tube is created by melting down, oils once again, and being molded into a shape. And then this tube, the other end of this tube will then connect into the glass jar and needs to be sealed with some sort of thread, which can be made from plastic, mostly plastic. There's also different polymers that could be used. There's just very many different kinds. And then lastly, the air compressor is then connected into the inlet, and air is discharged into the jar, creating a vacuum.
Transporting resources through a pipe, such as water, is no problem given that all conditions are favorable. But what about inputting such a resource? Luckily, we can use a bio-inspired hack that has already been put to use in today's world.
Alright, in the illustration below, we're looking at a concept in which we're going to be using Venturi tubes to collect rainwater at a much faster rate, because the Venturi effect will cause the flow to increase the collection in the tank. The illustration depicts one system, but the system can be easily extended to connect a series of Venturi tubes and pumps to allow more water to be collected and transferred out of the tank. This can be very beneficial to locations that are dry and arid and in which rain is very scarce. By collecting the rainwater in high volumes, when it does rain, we'll benefit by being able to use the water that's being collected in the future when there is droughts. The Venturi tubes and pumps can be used to transfer the water and transport the water out of the tanks, and can be sent to smaller tanks or irrigation systems. Once that tank is full, it'll be easy to transfer that water out at a fast rate also. And this concept will speed the process of collecting the rainwater and distributing all that water from the tank, by maximizing the use of the natural resource that we are basically given by nature.
So, that is all we need to consider for building a hypothetical Venturi-based tube pipeline system for transporting water and natural gas. What do you think of this solution? Do you think it is feasible enough for today? Do you think it can no longer cause any pipes to crack or freeze or burst open? Do you think we'll never ever have to worry about having no water during a major snowstorm or ice storm? These are the questions that are waiting to be answered through the use of bio-inspired design solutions like this one. Thank you.